Welcome to my presentation at the AMI Profiles Conference in September 2017 in Cologne, Germany. My name is Dr. Daniel Friedrich. I would like to report from Compolytics studies in the field of composite, polymer and policy analytics. And this presentation is about performance tests of plastics-based cladding profiles. I would like to touch upon the following subchapters. First, I start by introducing durability aspects in the design of plastics-based cladding. Then it is about long-term performance of PVC in cladding and presenting some study results conducted by Compolytics research. Then I would like to give you some basics about wind suction tests of PVC cladding and closing my presentation with a summary about the lessons learned. And how do we conduct such testing? There is already equipment available for laboratories, for example, such artificial weathering chambers, which test freeze-thaw cycling according to EN 321 for bio-based plastics, for example. And also UV impacts in combination with water spraying are tested for by such weathering chambers according to ISO 4892. So a lot of trials are done inside these chambers, and then we measure the loss of strength, and we get an equation describing this strength loss by dividing the strength of the conditioned specimens with the obviously lower bending strength values, for example, by the strength of the non-conditioned specimens. And here we get a value less than 1.0, describing how many percent from 100% the strength went down by this artificial weathering conditions. And this is called the nu factor for example, freeze-thaw cycling according to this chamber, or according to UV degradation following this artificial weathering chamber here. So we need this nu factor for transferring a resistance value from the characteristic state, which is indexed with K, to a design state indexed with D. And the proof is done when showing that the resistance value of such a facade section is slightly more than the expected impact from wind, and both is in the design state. But how do we get there to this resistance design state? Well, we need information about the characteristic resistance value, which we get from laboratory testing, maybe from bending strength tests. And these condensed values from test series are still in the characteristic state, and this can be transferred to the design state by multiplying with this aging coefficient, nu factor, which we obviously receive from these artificial weathering chambers, and then also dividing by a safety factor, which for facade application ranges between 1.5 and 2.5. So the nu factor is obviously a conversion factor transferring the virgin characteristic state into an aged design state. The difficulty is to get a realistic conversion factor nu. And for this reason, we conducted a literature research within the Compolytics study series, and we went through 44 different publications reporting about aging effects for polypropylene, polyethylene and PVC-based wood plastic composite materials, which were tested for artificial weathering in such a chamber where UV light and water spraying is applied. Also in freeze-thaw cycling chambers, and also tested for fungal decay. And you can see the results here, split by modulus of rupture and modulus of elasticity, which were both tested. And From this artificial weathering testing with UV light, we have something like 23% degradation for MOR and something quite similar for the stiffness modulus, followed by similarly high values from frost thaw cycling, but much less concerning the modulus of rupture. So obviously frost thaw cycling is more crucial for the stiffness modulus. And as far as fungal decay is concerned, the degradation values are comparatively lower, being round about 14% for the stiffness modulus and something like 7% for the rupture modulus. So obviously the most crucial for both MOR and MOE is this UV radiation, which is obviously very harmful for the plastics matrix. What we also found from this study, which is already published, and you can see the reference here, that PVC matrix is in WPCs caused higher initial MOE values, so this is leading to a stiffer material in contrast to polypropylene and polyethylene based matrix. And PVC matrix in WPC caused a lower nu factor for the frost thaw cycling degradation. So obviously PVC is a better matrix material when it comes to high impacts from frost thaw in practice. Then we were interested to find exact wind resistance values, because you remember 2 slides before we were talking about the RD values, which we obviously get from these characteristic wind simulation tests in laboratories, well described by the ETEC 035 following ASTM E72. And here we tested for 4 different plastics-based cladding profiles. 2 of them were WPC based, and the other 2 were pure PVC profiles. They were different in terms of wall thicknesses and also from dimension, but they all consisted of a groove and tongue system, which were mounted on a subconstruction here on timber subrails by screws, with pre-drilled long holes to also take into account thermal expansion in practice. They were mounted on the substruction. There were foil backs between the rear side of the profiles and the sub walls, and then they were tested for resistance against wind suction. And the test assembly is shown here. Here is the wind section installed according to the manufacturer's installation manual. The foil backs were in the ventilation segment, and then the foil backs were filled with pressured air, and we measured then the wind suction in kilonewtons per meter squared, until there was a failure of the complete facade section. And we also measured the deflection here in the mid-field of the spans. What we received were always a failure in terms of cracking of the fixation mechanisms. So either the screw heads were pulled through the complete panel, or the edge cracked around the screw head. So these were the basic failure modes, and we never received a failure due to bending rupture of the complete panel. And the values we received, you can see here for 2 tested field spans, 500 millimeters and 600 millimeters, and we received values from something like 12 to 13 kilonewtons per square meter for the WPC with the thicker walls, and then as second ranged one of the PVC profiles at third ranged the second WPC profile, and worst was the very thin PVC profile. And what you can also see here is that with a wider field span, the maximum applicable wind loads, they are slightly lower and going along with higher deflections. So the result is failure loads not necessarily depend on the material WPC or PVC, because you can see one of the two PVC profiles performed even better than the second WPC profile. So it's not only up to the material used, it's also up to the geometry, but also due to the fixation mechanism and the wall thickness, obviously. So what we should have learned from these Compolytics studies is that house owners and contractors, planners and site managers, they must ensure that all the erected building and building parts are fit for use and have sufficient structural safety. This is given if they were designed and installed according to norms, and the stability is checked by strength calculation, usually done by the facade planners or the structural engineers. The manufacturers of these profiles, they should provide design values with which one can do the strength calculations, and the design values, they can be derived from durability tests in climate chambers for freeze, thaw and UV, and by wind suction tests using foil bags as described before. A PVC matrix performed comparatively better under freeze thaw than under UV radiation. Here PVC is clearly an advantage to polyethylene and polypropylene. PVC cladding profiles with thinner walls are not necessarily worse against wind suction. It's more or less depending on the profile geometry and the fixation mechanism. So the arrangement of stiffening inner walls in such a PVC cladding profile might be decisive in wind resistance. This is a summary about the standards used, and also both described tests, they are already published in scientific journals, as you can see here, and you can search for them for more information. So I would like to come to the end of my presentation. I thank you for your attention, and if you're interested in further information about these researches, you will find more on the website compolytics.de. Thank you very much.